Hello and welcome to this video on Python. Python is a computer programming language widely used in physics. This is the first of a series of videos that will take you on a short walk through Python to get you started with computational physics. We start from zero. You don't need to have any previous knowledge of programming, or coding as it's also called. There is a lot to know in Python, but you don't need to know it all to get started. We will cover only what you really need, with perhaps a few steps to the side on the way. From here you can explore more Python as you need it, as all coders do. We will code in SPIDER, which stands for Scientific Python Development Environment. SPIDER is the Python IDE, or Integrated Development Environment, that is in the Anaconda distribution. The SPIDER interface opens with three visible windows, or consoles. At bottom right is the console for IPython, which stands for Interactive Python. This is where statements can be tested and where text output is shown. On the left is the Edit console, where a Python program is written, also called a script, and stored in a file with extension .py. This default file has the name temp.py. The script may be run from the toolbar at the top with the Run icon or from the Run menu. At the top right is a selection of consoles. The default is the Help console, and other options are the Variable Explorer, Plots, and Recent Files. Under the IPython window is also the History console that lists previous statements entered in IPython. Here is an example of Python code. It is a sequence of statements that a human can read, including English words, notation, and numbers. The words are only really borrowed from English and then given their own special meanings in Python. At the core of the Python language is a set of 35 keywords. A computer only understands binary numbers, so these statements must be translated into what is called machine code, written in binary, that a computer can process. Python is an interpreted language, which means that at runtime, when the code is run, a program called an interpreter translates each Python statement into binary machine code instructions, which are then executed by the computer. An interpreted program is called a script. The script is executed one statement at a time, in order, starting at the top and going downwards. Sometimes a statement will send execution down to a later statement, or back up to a previous statement, or outside the script to a program in a file called a module that may be one of many modules stored in a library. Every Python script automatically has access to the Python standard library with what are called built-in functions such as float, abs, and print. Just as in mathematics, a function is typically sent input values as arguments and returns an output value. The first two statements use the import keyword to import modules from two libraries we will use. The first is NumPy, or Numerical Python, which has many maths functions and other useful features. The as keyword creates an alias, which means another name for NumPy, in this case a short alias. The second library is Matplotlib, from which we select the pyplot module using the from keyword. We will use this to plot graphs. A comment following a hash symbol is not executed and is there to add descriptions to help a reader understand the code. It can be written on its own line or on the same line as a statement after the statement. The next statements are assignments that use the assignment operator to define variables of different types: integers, floats or floating point numbers that approximate real numbers, and an empty list, which is a type that contains other objects. The square brackets, always used by a list type, is an example of Python notation with a special meaning. Some statements perform arithmetic calculations using symbols for multiplication, division, and exponentiation, and there are others, such as the increment operator that increases a number by 1, or the in-place multiplication operator. An expression is evaluated to a value that is assigned to a variable, such as an arithmetic expression. Expressions with relational operators, such as is greater than and is less than, evaluate to Boolean values true or false, which are both keywords. A Boolean expression has Boolean operators, such as the AND keyword, and evaluates to true or false. A statement can use a function, such as built-in functions, or functions from an external module, which is why NumPy was imported. A function bound to a data type is called a method, accessed with the dot operator. The assignment statement, whether for defining variables or evaluating expressions, is one of three main kinds of statement in Python, and in computer programming in general. The other two kinds are control statements, which control the flow of the code. The if keyword is used to test a condition expressed as a Boolean value, and if it is true, then the indented set of statements is executed. This indented block is called a suite, and it follows the colon that terminates the header if statement. The colon is an essential piece of notation in Python. Don't forget the colon. If the condition is false, then the suite is not executed, and execution skips to the next statement after the suite. The if statement provides conditional control because it performs a test on a condition, which is one of the great strengths of a computer, because it allows a basic kind of decision making. The for and while keywords define a loop, which allows execution of a piece of code for thousands, millions, or billions of operations, and is another great strength of a computer. The for keyword defines a suite that is executed a set number of iterations, specified here by a range iterator that generates a fixed sequence of integers. For each integer extracted by the in keyword, the suite is executed, and the integer n can be used in the suite. The other loop keyword is while, which executes its suite as long as the Boolean expression in its header statement evaluates to true. Note the colons at the end of the for and while header statements. Indentation is required in Python. It is in the rules and makes the code more readable and hence easier to understand. Indentation sets off various blocks of code from each other so you can see each block at a glance. A block of code is a general term to describe a set of statements executed as a unit. A whole script is a block, and so is a suite. Blocks and suites can be nested as suites and subsuites, or blocks and subblocks. At the end of the code, after all the statements have been executed, many times if in a loop, the built-in print function shows output in the IPython console. Note that the text is between single quotes. This is called a string in Python, meaning a string of characters, which is a data type for text. Finally, the plot function from the pyplot module is used to display a graph. In this example, we have actually covered most of what you need to get started with computational physics. But some more explanation will be useful in the videos that follow.